Okay, solving quadratic equations using the quadratic formula, part 1. So first of all, copy this down, pause the video. This is the quadratic formula, and we're going to look at an example. So, example 1, don't forget, pause the video and copy this down. So here we have an equation. And it's quadratic. Okay, it's a quadratic equation because the power, the degree, the highest exponent is 2. Okay, that tells us that this is a quadratic equation. Remember, quadratic equations make parabolas when we graph them. The first thing we need to do is take this equation and we need to put it in standard form. So to get it into standard form, I'm going to go ahead and I'm going to move everything over here to the left. So that way my A value here is positive. So adding it onto each side, that will cancel it out. Adding the 5, canceling out. So we're going to have 2x squared minus 4x plus 5 equals 0. Now we're in standard form. Okay, that's very important. Next thing, we need to identify the A value, the B value, and the C value. So A is located right here. That's going to be our A value. Our B value is right here. That's going to be B, -4. And then our C value is 5. Okay? So once we have identified A, B, and C, we plug them into the formula. So the negative is part of the formula. Then we input the B value, which in this case is -4, plus or minus the square root, input the B value, input the A value, and input the C value over, and then we have 2 times A, so 2, and then input the A value. Okay, so take a moment, make sure you understand. Also, it's a good idea to use parentheses for multiplication. Okay, so we have a negative times a negative, which is positive 4. A -4 squared, which is 16. -4 times 2 times 5, that's going to give us -40. And 2 times 2 is 4. Continuing to simplify, we have 4 plus or minus, and underneath the radical we have -24. Now this number right here is known as the discriminant. And in part 2, I will talk more about what the discriminant tells you about the solutions. Right now we are in part 1. Okay, so here's where we dive into the imaginary part, because we want to simplify this answer, and we can't have a negative under a radical. So remember, we pull the negative out and it becomes I. And in case you forgot, I equals the square root of -1. Okay, continuing to simplify our answer. The square root of 24 has a perfect square factor of 4. Okay, so the square root of 24 breaks down to the square root of 4 times the square root of 6. So we end up with 4 plus or minus I times 2, or 2i, times the square root of 6 over 4. Now notice that all three of these numbers, don't look at this one, but all three of these numbers are divisible by 2. So I could simplify this by 2. So what we have here is 4/4, which is 1 over 1, 2/4, which is 1 over 2. So if I divide all three of these numbers by 2, we get, I'm going to go ahead and do it a little bit differently than that, because I want to take a 2 out of each term. So 2 goes into 4 2 times, 2 goes into 2 1 time, and then 2 goes into 4 2 times. So we could leave our answer like that. And this is 2 complex solutions. Missing a letter here. Complex solutions. And they are, now the plus and the minus, so one of the solutions is 2 plus I radical 6 over 2. That's using the positive part, the plus part. And the other solution is going to be 2 minus I radical 6 over 2. So that represents the two solutions to this problem. Now let's take a look and see what this looks like. If you plug the equation in standard form into y equals, so here it is in standard form, and you graph it, notice that the parabola does not cross the x-axis. This is where all the real solutions exist. Okay? But instead, the solution exists up here. If you'll remember from the video, notice our real portion is 1. And then our imaginary portion is right up here, which in this case is I radical 6. Actually, it's it's actually 1/2 I radical 6. And so there's where our complex solution exists on the graph. If you remember from the video, we had our real number system, and then we had the imaginary with the negative imaginary numbers and the positive imaginary numbers up here. So that represents our complex solution at that point. Okay, so we're at 8 minutes. I could go on, but I will save more information for part 2. We'll see you in class tomorrow, and have a good evening.